Today's tutorial video is on velocity. Yesterday we talked about a few things like distance, we talked about time, we talked about the ratio between the two of those. Distance divided by time gives us the speed. These are all what we call scalar quantities, quantities being numbers. Scalar quantities show the amount of a quantity, but not direction. So time is a scalar quantity because 10 minutes is 10 minutes no matter what direction you go. So is mass. No matter what direction you go, your mass is your mass. Vector quantities show the magnitude and direction of the quantity. Vector quantities are written with an arrow above them. You'll notice in your notes it's just a sideways L. Difficult to get a little arrow to put above text. So one way we might see this described is 50 kilometers north. We don't use the word distance to represent a vector quantity. We use the word displacement. There's an image here which shows the difference between distance and displacement. Distance might be this path that you walk around a lake to get to a point B. Displacement is exactly how far you are away from your starting point. So this displacement would be also described with a direction. You would say, well, you've gone a certain distance, maybe southeast. So displacement, say this path looped around, continued on. Your distance might be quite significant, but your displacement could be zero, because if you end up in the same point as you started, well, your displacement, your total distance that you've moved from that reference point is zero. How do we identify vector quantities? Well, we think of things like forwards as positive numbers and backwards as negative numbers. We can also use north, south, east, and west to identify them. So north is a positive number, and up is a positive number. South and down are negative numbers. To the east, just like when we are doing graphing and math, east is positive, and to the west is negative. So just like our coordinate graphing. Now vectors, we have to keep in mind those positive and negative numbers when we are adding them together. If we go 3 units east and then 7 units east, those add together to make 10. If we go 10 units east and then 3 units west, well, I need to subtract those 3 units. So my total overall distance would be 7 units to the right. And then that is a displacement, that's a vector quantity. So yeah, yesterday we talked about speed. You cover a certain distance and you divide that by the time, and that tells you your speed. You'll notice the person walks 6 meters, turns around, and then walks another 4 to get a total distance traveled of 10 meters. Your step counters would work like this. No matter what direction you're going, you're counting your steps forward. Velocity is a vector quantity. You'll notice we use displacement instead of distance in the velocity formula. And watch the person travel 6 to the right and then 4 to the left to get an overall displacement of 2 meters to the right. To find your average velocity, you take that 2 meters that you've traveled to the right, divide it by the time it takes, and you get a smaller velocity. So we use the same formula. It's just we would identify displacement with an arrow above it. So we're going to go through an example on page 8. You're welcome to do it on your own, and then you can check in with this video. We have a bird on a branch of a tree that's 10 meters in the air. The bird flies down to the ground and then up to the top of the tree, which is 15 meters high. The total time of flight is 4 seconds. So it's useful to do a drawing. It doesn't have to be as pretty as mine, but that allows you to kind of see what's going on. So the bird flies down to the ground, 10 meters, and then up 15 meters to the top of the tree. So the total distance traveled would be 10 meters to the ground plus 15 meters up to the top of the tree equals 25 meters total. Our displacement is going to be different because our displacement is how far away its final point is from its starting point. So we can use a negative number to represent down. It goes minus 10 meters to the ground from its original starting point. It then goes 15 meters to the top of the tree. That leaves it with a total, it's only gone 5 meters from its original starting point. And you would say 5 meters up. So the average speed is a distance divided by a time. The distance is 25 meters. The time is 4 seconds. (25) divided by 4 is 6.25, and we look to our symbols that we've been using, meters per second. Velocity is a similar formula, but we, instead of using distance, we use our total displacement. Our total displacement is 5 meters up. Our total time is still 4 seconds. 5 divided by 4 is 1.25 meters per second. And then we're still identifying our direction, which is up. So this example goes through the difference between distance and displacement, and then the difference between speed and velocity.